In this short video, I'd like to just make a couple points about the uniqueness of water. And basically, I intend this just as a supplemental video lecture to our discussion of Chapter 12. And there are a couple of things that I'm going to talk about here, but I really want to start off with the structure of water, because here, as we saw this figure from our slide, you have a water molecule hydrogen bonding to another water molecule, and that water molecule is hydrogen bonding to three other water molecules. But you see that water has this unique ability that comes from its structure, and that is very, very small as a molecule, but yet it has 4 hydrogen bonds for a molecule that is actually quite small. It is the only molecule of its size that can participate in 4 hydrogen bonds like it does. And this property of hydrogen bonding is basically what gives water its unique properties, and this is where its unique properties come from: its small size and ability to do extensive hydrogen bonding. Now, we could summarize these properties, and our book does this, and I just want to highlight these from the text, where we could talk about the solvent properties as we do here. And of course, these solvent properties result from the overall polarity of water and the ability to form a high density of hydrogen bonds, as I was just discussing. That gives it the ability to be a very effective polar solvent. So if you have a polar substance, something say even as polar as an ionic substance, water has the ability to dissolve ionic substances. Now, and remember, ionic substances have very strong bonds. As a matter of fact, the melting temperature of ionic substances is usually very, very high, in hundreds of degrees. However, an ionic substance can be dissolved, and that means these ionic bonds are, in essence, broken. But the way that this takes place is what we'll talk about in the next chapter, basically how water will surround ions with a compatible ionic charge. And so the ionic charge of the ion, if it's positive, then the negative end of the water will surround the ion and basically gives the water this very strong polar solvent ability. And we'll talk more about that in chapter 13. However, the ability to dissolve ionic bonds means that water also has the ability to conduct electricity, particularly when it has ions dissolved in it. And this conductivity is something we will come back to later in the semester. But this is an important solvent property of water, that it is a very polar solvent and has the ability to dissolve ions. Now, with respect to the thermal properties, one of the things about water is that it has a high heat capacity. This means that basically water can buffer temperature change. So water can absorb a significant amount of heat per degree of temperature change. And that's what it means to have a high heat capacity. So if you've got a heat capacity of over 4 joules per degree Celsius, then that means that substance will absorb 4 joules per degree Celsius per gram of substance, whereas you might have some substance like ethanol, which has a much lower heat capacity. And the high heat capacity of water allows it to buffer temperature change both in our bodies, but also on our planet. I mean, the fact that our planet is covered by 70% water is significant to the temperature regulation that takes place on our planet. It has a lot to do with this large surface area of water, its ability to absorb the radiant energy that comes from the sun. This allows basically a buffer in the temperature of even on our planet, so that we have a relatively small temperature change range, which actually allows life as we know it to exist. So if you think about that, I mean, our book talks about it in more detail, but I thought that was a very interesting point. And I check out the text if you want to read more about that. Now, another really important thermal property is the large change in enthalpy of vaporization, or delta H vaporization. What this means is that when water evaporates and goes from the liquid state into, so delta H of vaporization is heat of vaporization. So when you evaporate water, That means it takes a lot of energy to evaporate water. But that also means that when water evaporates, it takes with it a lot of energy. So if say you're very hot and you have sweat evaporating off of your brow, that sweat, when it evaporates, takes a lot of energy from your head and basically transfers it into the air around you. And that ability to sweat actually keeps you from dying. People who have difficulties with being able to sweat have to be very careful to keep of the environments that they find themselves. You can't go outside and get overheated, because if you don't have the ability to sweat, you can actually overheat and die. There are even some animals, like pigs, don't have the ability to sweat very well. And as a result, pigs are very susceptible to heat exhaustion and heat death. So large enthalpy of vaporization means that when water evaporates, it takes a lot of heat with it. And that's what we mean by heat dissipation. And then finally, we're going to talk about the surface properties here, and the uniqueness of this surface tension. Because of the very high surface tension of water, one of the things it does in terms of the environment is it keeps plant debris on the surface of the water. Now, for environmental reasons, this basically will provide shade for fish and bugs, but it also provides food, so that all of the plant debris doesn't immediately sink down, but it will stay on the surface and then sink down more slowly, providing both shade and food for fish and bugs. And then there's another important surface property we talked about, the capillarity of water. Or capillarity, but water has a very high capillarity, which what this means is that water will rise very easily through the soil. So if you have a plant and the dirt around it is very, very dry, but if it has deep roots that go down, then those deep roots they may be in a dry soil environment, but as the soil is very dry near the top, then water from lower down below will actually rise through the soil up to the plant roots, where it allows plants in very dry situation to basically stay alive by pulling up, or being able to get this water with its roots. And of course, this also means that water moves through soil fairly readily. Soil is not a barrier to water because of this high capillarity. Now, the last thing, and one of the things that's kind of unique about water, is because of this hydrogen bonding. We had talked about this a little bit in lecture, but I just wanted to kind of throw it in here in this discussion, is that because of the ability of water to form these 4 hydrogen bonds, it is one of the few substances that actually is less dense in the solid form than it is in the liquid form. Now, what this means is that water expands upon freezing. So when it goes into the solid phase, it actually, in order to satisfy all these hydrogen bonds, it adopts this hexagonal phase crystal, which means that it basically expands its structure. And in expanding its structure, that means solid water is less dense, and therefore it floats on top. Now, this also has environmental impacts in that water, as it's freezing, it will not freeze at the bottom of the lake first. So lakes don't freeze from the bottom up. So generally, the surface will freeze, and depending on how cold it is, it will freeze down some distance. But typically, lakes do not freeze over solid. And so organisms and animals that can swim down to the lower levels, they can survive the winter by staying in the liquid part of the water. And basically, whenever the water thaws, of course, then they have access to the surface again. But the whole idea is that because the water doesn't freeze from the bottom up, it freezes from the top down, that leaves pockets of liquid water where organisms can survive throughout the winter. And this has, biological implications. So the main point that I'm trying to get in this video is that because of its unique structural properties and chemical properties, it has a very interesting impact on life as we know it. And that's why when people are looking for planets where life might exist, one of the number one things that is mentioned is, does the planet have water? And that would be because life as we know it depends very intimately on water in its chemical properties, and the physical properties that arise from the chemical properties.